So we're going to look at how we can use the Maclaurin's series to find limits. So let's just start off and see why we can't actually use a limit of 0 into here. So if we put 0 into the top, we would have e to the power of 0, which is 1. Then we take away nothing. Then we take away 1, which gives me 0. And then we're dividing it by 0 squared, which is 0. Now we can't do 0 divided by 0. We could try doing something called L'Hopital's rule, which is also on the syllabus, but we're going to use Maclaurin's here. So let's see if we can do this by using Maclaurin's. We're going to expand just this part here. Now, if I go back, e to the x is one of my expansions that I was doing earlier. So e to the x is here as one of my expansions. So I'm using that e to the x expansion, but I'm going to substitute in e to the 2x. Now you can double check this expansion that I'm doing here, but e to the 2x can be expanded to give me 1 plus 2x plus 2x squared divided by 3. Now I'm going to do the first 4 or 5 of these cubed, and I'm just using the formula sheet but putting in 2x instead of x, and then I think the next one is 2/3 x to the power of 4 over 3 again. Now that will carry on. Now from that I'm going to take away 2x and I'm going to take away 1. So basically I can say that that's not there and that's not there. So my expansion becomes simply 2x squared divided by 3 plus 4x cubed divided by 3 plus 2x to the power of 4 divided by 3. And it carries on. The next thing is I've got to divide it by this 2. So we have this x squared rather. So every single part is going to be divided by x squared. So the first part becomes 2/3. Now the next part becomes 4x divided by 3, and then we're going to keep having our x's in there. We're going to have the next term is going to have some x's in it, and so on. Now if x now goes towards 0, which was our original problem, we get 2/3, and then we've got, this is perfectly legitimate, 4 times 0 is 0 divided by 3, so it's nothing. And because we've only got the numbers on the bottom, 3, 3, and the next one might be 9 or 27, but we've got x's on top, we're always going to end up with these zeros. So we've got our limit, which is 2/3. So this is how we found a limit using Maclaurin expansion.